Hi everyone, welcome to today's webinar. We'll just wait for some time and wait for more people to join and we'll just get started in some seconds. Thank you very much for joining. We really value your time and energy.
Hey, hi Ashpreet.
Hi Ashpreet.
Hello there. Hey Vishwajit.
Hey, hello. Good morning.
Good afternoon. And is that Yukti? Have we been communicating
Yes.
over email?
Hi.
Nice to meet you as well.
Nice to meet you guys. I think we have enough numbers. We can start now. Okay. Um, Hello, everyone, and welcome to our webinar, Build AI Apps and Agents in Minutes with Phi Data and SingleStore. My name is Yukti Dwivedi, and I work as a growth analyst at SingleStore. And it's my pleasure to be your moderator today. One of my main jobs at SingleStore is to organize weekly AI webinars. We organize 2 webinars per week, sometimes 3, demonstrating AI and data use cases and new tools and technologies. I will post about our upcoming webinars every week. So if these topics are interesting to you, please feel free to connect with me on LinkedIn to stay in the loop. I'd also love to hear your feedback or ideas on the topic you'd love to see in the future sessions. So speaking of future sessions, we've also got great sessions coming up this week. On Friday, we'll present Gemini 1.5 Pro native audio file API JSON mode and 1 million context window. Come to see a live demo to see how you can leverage this technology. And RSVP right now at the link. I'll just put everything in the chat. On Monday, we have Is RAG Really Dead, which is 29th of April. And it's a hands-on demo to just explore what is happening with Google Gemini and what's the situation with RAG right now. We will have great experts to speak. And on the 30th, we have Meet Llama 3, run locally with more power, less cost, full privacy. I'll personally be attending this demo. Sounds really interesting. Okay, so back to today's topic. You're welcome to participate in discussion throughout the session using the Zoom Q&A button. At the bottom of your console, we have an internal mission to answer the statement questions of all the audience. And even if that means following up with everyone after email, so please ask away, do not hesitate. But make sure that you have logged into Zoom with your email address and your name, because we won't be answering any anonymous questions. I hope that's understandable. We'd love for you to have a dynamic experience during this webinar, so please feel free to leverage SingleStore DB as you watch. Anyone who tries it out today will be entered for a chance to win either new branded AirPods or Meta's new Ray-Ban LLM smart glasses. It's your choice. Simply click this link that is there in the presentation. You can scan the QR code. I'll be putting all the links in the chat and log in. SingleStore has had a free trial offered for many years, but in the past few weeks, we have also announced a free shared tier. We'll talk about it a bit later. Please allow me to introduce our speakers today. Please welcome Ashpreet Bedi, the founder of Phi Data, a company building autonomous AI products. As a skill leader in AI technology and innovation, Ashpreet has significantly advanced his company's position in the competitive data solutions market. Thanks to his strategic acumen and impactful leadership. Thanks a bunch for joining us. We really value you, and it's lovely to have you here. Also joining us today is Vishwajit Dabolkar, an enterprise solutions engineer with SingleStore. His expertise in developing sophisticated solutions for complex data challenges has been a key to empowering businesses to optimize their data-driven strategies. Welcome, both of you. We are so happy that you guys have joined. In today's webinar, we'll explore how to utilize Phi Data's intuitive drag and drop interface for building AI models without any coding, integrate AI seamlessly into your existing workflows, and provide step-by-step tutorials and comprehensive documentation for both platforms. Ashpreet, the floor is now yours. Thank you so much, everyone, for joining. Please, let's start. Thank you.
Well, thank you so much for having me here. It's an absolute pleasure. But I think the next few slides, Vishwajit's going to talk about a RAG approach and how SingleStore fits in. So I'll let him take over.
Hey, thank you guys. Thank you, Yukti, for a great introduction. Ashpreet, you will have a great opportunity coming forward to explain a lot of code to people. I think people are here mostly interested about how they can utilize the Phi Data library to build very awesome agentic RAG applications. So I'll talk about emerging architecture for LLM apps. Right now, I think most of us are aware about the RAG, or retrieval augmented generation technology. Basically, it's giving ability to your LLMs uh, to talk about or to answer based on your private data, your company's private data, which you cannot make public, or which is specific to your projects or to your organization, right? And the need for RAG is so that your LLMs do not hallucinate, right? We do not want LLMs to give wrong answers. Mostly we have seen, right? LLMs have the tendency to make stuff up, right? When they cannot answer, which sometimes is very funny, but not in a production environment, right? So let me talk about a little bit about what is retrieval augmented generation, or RAG, right? As I said, your company has some private data which is being generated in real time. For example, this webinar, whatever we are talking about or will be discussing about is the real time data that is being generated, right? And let's say someone goes and they want to know about what we are discussing, and they want to understand about it, and they want to ask questions about the topics being discussed on this, right? That real-time data is generated, that will be vectorized and put it into a database, and that data vector database will be used by your LLM or RAG application, where you'll do semantic search. Basically, you'll have a query. For example, what did Vishwajit and Asprit talked about, right? We are talking about RAG or building agentic apps, agentic RAG apps using Phi Data library, right? Now, when a person asks a question like what Vishwajit and Asprit are talking about, we take that question, we create embeddings of that question, and we do a semantic search against the stored vector data of the, well, let's say currently for this webinar, whatever the data is, we have vectors for that. And against that, we do either dot product or Euclidean distance, and we get most similar data or knowledge base, which we provide it to our LLMs. And then they give you, a structured answers. Like they'll talk like, hey, Vishwajit and Asprit are, Vishwajit and SE, Asprit is a founder for Phi Data, and they talked about how to use Phi Data library to build agentic apps in minutes, right? That's how our general workflow goes, right? How this is helping is your LLMs have been trained on specific amount of data. They do not have your private data. For example, it's a documentation of SingleStore. You can check out our Squirrel bot. Once you go and try out SingleStore on our UI, you can check out our Squirrel bot, which has been built on the similar kind of terminology of a RAG. You can ask anything about SingleStore to it, and it will answer you based on the SingleStore documentation regarding that, right? Let me talk a little bit about SingleStore, what we are and what exactly we do. So basically, SingleStore is a database to do transact, analyze, and contextualize data in real time. So we support data storage in both row-based and columnar store formats. We are very, very fast. It's an in-memory database. It's a distributed SQL, and it's horizontally scalable, right? We are here with SingleStore, you get the speed of a transact database, and the power of a analytical database, because we also support columnar data storage. You can run your large aggregations on top of it, and you can still see the performance of a transactional database. We had support for vectors since 2017. Now we have also added vector data type. We have introduced our own vector indexes, which supports HNSW, PQ, and IVF type of indexes. We can talk about that in the coming slides. We also support different types of data format like JSON, time series, geospatial, right? Vector data, right? Let's see how SingleStore works under the hood. So we have we have our tool pipelines, SingleStore pipelines, which allows you to ingest data from sources like S3, any object store, S3, GCS, Azure Blob Storage. your local file system. From there, you can ingest your data in real time using single store pipelines at a very, very fast scale. And when your first data is firstly ingested, it comes into your memory, and then it is put into local disks, and then it is stored on the object store based on the usage or recurring querying of the data, right? We have something called universal storage. It's a patented technology, right? The best thing about this is like single store pipelines support not just ingestion from your file storage. You can ingest data from Kafka. You can ingest data from any other source you have. We also support MySQL and Mongo CDC pipelines. So you can directly ingest data from MySQL and Mongo using our pipelines into single store. You do not need to have your separate ETL tool for that, right? It's a three-tier architecture, and we support multi-model data storage in it, right? We also have single store follows master slave architecture. You can check it out on our official website. Akmal or Yukti would provide a link for that. And moving forward, these are some of the single store's key capabilities. We just talked about fast ingestion of single store pipelines, right? We have something called bottomless storage. Basically, you can store we have our compute and the storage separated, like they are segregated. Like you only pay for you only pay for your compute, and you pay very, very minimal amount for your storage, so you can have the best in class storage, right? Of course, we have something called MongoDB API. We call it single store Kai. Basically, you can query a Mongo database using this API. One of our new features is our notebooks and the jobs of notebook, right? You can take any of your analytical workload where you are querying some data and generating some graphs using Python code, and you are using Plotly or something. You can use a single store's Jupyter notebook integration to execute those code at a very fast speed. We have a lot of features. For example, our Squirrel bot is integrated with notebooks. So whenever you are writing a query on your database, you can just ask questions to Squirrel, and it will write the code for you into the notebook cells. We also have single store jobs where you can schedule those notebooks for any kind of analytical workload. For example, let's say you have a Python code or a logic which you have saved into notebooks, where you're doing some kind of a processing or ETL on a certain amount of data. You can use these notebooks to write that data into S3 using jobs. Like you'll have your own scheduled notebooks, which at a certain time will do data processing and will store your data at your location. Either it could be in single store, or it could be in S3 or any other storage of your choice, right? Let's talk about the simplicity, speed, and scale of single store. As I said, single store supports like any data type, right? We can store JSON, we can store vectors also, right? The best thing about JSON is, right, you can do ETL on the fly. For example, you're ingesting JSON data from S3 to single store. Earlier, what used to happen, let's say I'm reading from S3 and writing into a data warehouse kind of a storage. We are using Spark Job. Even now, people use Spark Job, right? So almost all of you must have faced that. Expanding a JSON in Spark is a headache, right? It's always a headache. But with single store, you can just use pipelines with into procedure, and you can easily flatten out your JSON and ingest into multiple tables using a procedure on the fly, right? And talking about the speed, we have a hybrid search enabled demos also available, where you can do semantic search, that's a vector querying, and full text search, like a keyword search using single store, and you will get the most fast responses ever. And of course, you can scale the database for petabyte level of data, where you can do both transactions and analytical queries, and you will get the most of it, right? Now, this is a screenshot of our notebooks. Do check it out. You can just sign up for a free trial, and you create a free notebook. We have multiple demos available or multiple demo notebooks available in our gallery section. I'll show that before I hand it over to Ashpreet, from where you can just start checking out the different Gen AI demos or any other demos we have built and made publicly available, right? This is something called SingleStore Spaces. The demos which I talked about are available in SingleStore Spaces if you just want to check them out. And if you want to run them directly, you can check them out into our gallery page. Now, without boring you all, I'll hand it over to Ashpreet for the most interesting part of building actual Phi Data agents in the code format. And we will be sharing all the codes at the end of the meeting in the chat, and you will also receive that on an email after the with the recording, right? Ashpreet, over to you.
Thank you so much. Vishwajit, are you going to be sharing the presentation?
Yep, I'll share this one. Yeah.
All right, perfect. Thank you, everyone. Hi, it's Ashpreet, and I'd like to introduce Phi Data, which is a framework for providing memory, knowledge, and tools to LLMs. So we're going to be using Phi Data today to build two types of assistants. First, we're going to be building a research assistant that'll take a complex topic, search the web or our knowledge base, which is in SingleStore, and produce a neatly written report for us. And then we're also going to be building a RAG assistant that can search a knowledge base and answer questions based off PDFs and websites. We're also going to be introducing something called agentic RAG or autonomous RAG, in which we don't automatically provide information to the LLM, but we let it search the knowledge base, search the chat history for what it needs. So next slide, please. So while we're building this AI apps, one of the things which we notice when we're using the LLM APIs is that they have limited context and cannot take actions. So as Vishwajit was talking about RAG, this was the main point, that the LLMs do not have context about our business processes, our business data, or the previous chat history. Along with that, they cannot take actions like make API calls, search the web for real-time information, send emails. We're going to be enabling that for LLMs today. So what we found with Phi Data is that we can improve these LLMs by giving them long-term memory, meaning storing their chat history, summaries, entities in a database like SingleStore. Then we also provide them with contextual knowledge by storing PDFs, web pages, JSON in a vector database. Again, we'll be using SingleStore today for this. And then finally, we can also provide them tools to access data in real time. They can search the web, they can make API calls, they can send emails. We'll showcase this functionality, but in a very limited manner today. So all of the code for Phi Data is open source on GitHub. We have a number of cookbooks, so please go check them out. And without boring you any further, let's get into the demo. All right, so what we're going to be doing today, as I mentioned, is we're going to be building two AI apps with SingleStore and Phi Data. The first one is a research assistant. It's going to take a complex topic. It's going to search the knowledge base and produce a research report for us. One thing we're going to be doing is we're going to be using the new Llama 3 models. We're also going to try and run them on Grok. So for super fast inference at 800 tokens per second. And then the second AI assistant we're going to be building today is a RAG assistant, in which we'll run Llama 3 locally. We'll scrape websites for knowledge, and then we'll answer questions of them. Again, with all of these, we're going to be using the Llama 3 LLMs. We're also going to be having the GPT-4 LLMs, and we're going to be also introducing the new Phi 3 LLMs, which were just released yesterday. So you're going to get a pretty nice cutting-edge overview of the AI market right now. So the next step requires me to write and share a lot of code with you. So mind if I take over, Vishwajit?
Absolutely, Ashpreet. Go ahead. I'm very excited to check this out. I hope everyone else is also excited, because Phi 3, as you said, was launched yesterday, and I'm really excited to see the performance.
Me too. All right. So what I'm going to do is I'm going to share my PyCharm and my Google Chrome. Everyone can see my screen?
Yep.
All right, fantastic. Let me just move the Zoom windows out of the way. And let me give you a little bit of overview of what we're going to be building today. Again, we're going to be doing this step by step, so you can follow along if you'd like, but I do want to show you a little bit about what we're going to be building today. So as I mentioned, it's going to be two SingleStore AI applications. All the code is going to be there for you. you can go onto git.new/s2/phi to access this code as well. It's going to take you to the Phi Data cookbook where all of the code for these two applications is there. But before we do that, let me show you a little bit about what we're going to be building. So as I mentioned, the first AI app we're going to be building is a research assistant. What I did is I gave it a couple of SingleStore blog posts. I gave it this one. I gave it how to choose a vector database, hybrid search, and the new SingleStore vector database information. And I've given it a couple of LLMs, the Llama 3 running on Grok, and I want you to check the performance of this app, along with GPT-4, Phi 3, and Llama 3 running locally. So you can do this entire tutorial free of cost locally on your machine. Over here, what we're going to do is, to a research assistant, we're going to say, write me a research report about SingleStore vector search. It's going to search its knowledge base. Okay, let me just refresh this. I think it was a connection issue. It's going to search its knowledge base and then generate a report. Look at that speed powered by Grok. It's going to write a proper research report based on the SingleStore blog post. And if you want to compare this to GPT-4. I also uploaded the same information to GPT-4 LLM. And just compare the speed which we're getting with GPT-4 compared to Llama 3. Let's go back to Llama 3. I think that's a lot more fun for us right now. Another thing which we're going to be doing here today is we have, along with the knowledge base, which is based in SingleStore vector storage, we also have web search. So this can even search the web along with the knowledge base. Web search obviously takes a little bit of time, but it can write a research article based on web search as well. The next AI assistant we're going to be building today is the RAG assistant. Again, I've uploaded some of these blog posts on there, and we can ask questions. Help me, or how do I choose a vector database? Running on Grok, look at that speed which it provides to us. So it mentions, it gives us a full report, and we can chat with it now. So without further ado, this is what we're going to be building today. Let's get into building this step by step. I'm going to turn this application off. And what I'm going to do is I'm going to share in the chat this link for git.new s2/phi. Let me just open up the Zoom chat.
We shared that link, Ashwin.
Okay, perfect. Thank you. Please already shared it. Thank you so much. So over here, what you're going to notice is you're going to come to this Phi Data cookbook. So the Phi Data repo, fully open source. You can fork and clone this repository while you're at it. Give it a star as well. So once you clone this repository, you'll be able to see it in your favorite code editor. I like using PyCharm. You can use VS Code, Sublime Text, anything you like. So under here, we'll be under cookbooks, integrations, SingleStore, and AI apps. So under this SingleStore AI apps, we have full step-by-step about the AI apps we're going to be building today. We're going to be accessing the following LLMs: Llama 3, 8 billion, which runs locally. So free of cost, no API key needed. Llama 3, 70 billion running on Grok. This is my favorite LLM right now. It is amazing performance at blazing fast speeds. And again, GPT-4 as well. It's unanimously the king, so it's always good to have it in there. So step by step, let's do this. First thing we're going to do is we're going to create a Python virtual environment. It's all code-based. So we're going to first create a Python virtual environment using these two commands. This command creates it, this command activates it. Then we're going to install the required libraries. We're going to install Streamlit, Phi Data, Ollama, Grok, OpenAI, all the libraries and SingleStore which we're going to be needing today. And then the next thing which you'd want to do is you want to export your credentials. Now, if you're following along, I'll give you a minute here to create your database on SingleStore and export those credentials. So when you go to SingleStore, and let me go to the home page, you see this homepage for yourself. over here on the cloud one, you can create a shared database for yourself. Now, I wanted to do this entirely on the shared plan with SingleStore, the free shared tier. SingleStore is a fantastic vector store, a fantastic database, and it is pretty much my choice right now for any sort of cloud workloads. So I want to show you how powerful it can get with just the shared free tier. So go ahead and create your database, and then you'll get, once you've created your database, you'll be able to see the connection instructions. So over here, you can see the host for it, the port, username, the password, and the database which you're going to use. So once you have that information, you'll have to export that. Another thing, if you're on the shared tier, you'll have to provide a certificate file for the SSL connections. Please do export that as well. All of this information is taken by the assistants we build. So they're accepted using environment variables.
Ashpreet, could you please just show people like where do we get the SSL on the same page? Yeah, on there.
Absolutely. So when you do connect CLI client, you can see the TLS and SSL certificate. You can click on download and it'll download it for you. It'll be SingleStore bundle. And I pretty much put it at the .certs SingleStore bundle repo, which is under my home directory. So Vishwajit, do you think we should wait a minute or two, or?
No, I think we are recording this, so let's just move forward, right?
Perfect.
And if anyone is following along and you have any questions, feel free to ping us. I'll answer them while Ashpreet is walking us through the demo.
Brilliant. And we'll be here for a Q&A as well. So all of them are step-by-step, which I think it makes sense to work at your own pace as well. Then depending on the LLM you'd like to use, export the API key. So I've exported it for OpenAI, I've exported it for Grok. And if you want to use Twilio search, you want to export the Twilio API key as well. In a way, you can skip all of these as well. It's fine. We're going to be running these LLMs locally. So this can be completely local as well. So export them if you'd like to use these features. Otherwise, everything will work locally too. The next step for us is to install Ollama and run the local models. So Ollama is right now one of my favorite toolkits. We can use it to run local LLMs. So go onto the Ollama website, their GitHub, download it from Mac or Windows or Linux, whichever platform you're on. And once you've installed it, you're going to pull the models which you need. So we're going to be playing with the embedding model, Nomic Embed Text. This is a fantastic model, pretty much on par with OpenAI embeddings. And we're going to be pulling the Llama 3 model. So I'll do that in front of you. And the same thing with the Llama 3 models. It'll probably take a little bit of time, so it kind of makes sense for us to move ahead with this. Llama 3, it's a 5 GB file, so it will take a bit of time for you to run locally. If you want something smaller, Phi 3 is turning out to be fantastic as well, so you can pull that too. That as well is 2.5 gigs. The final step for us is to run our Streamlit application, and this is what runs our 2 AI apps. So let's run our Streamlit application, and here we go. Let me close the previous one. So this is our Streamlit application. It has the research assistant and the RAG assistant. One thing which I'm going to do right now is I'm going to clear the knowledge base, pretty much clear the data in the vector database. Let me go to SingleStore, develop. I'm going to show tables. So these are the 4 vector databases, vector tables which I'm using. I'm going to clear all of them. So I'm going to do 1, 2, 3, 4. Now I have no knowledge in there. I'm going to restart it. And I'm going to show you, if I do it right now, it's going to not give me a good result. It's going to say I couldn't generate anything. There's no knowledge. So what I'm going to do is I'm going to take this blog post and say, add URL to knowledge base. Behind the scenes, what you'll notice is that it's going to crawl this that blog post and add it to the vector database. I think because we did a little bit of tricks over here, it said ran a bit of an error. Let's add it again. That was just a database connection issue because the table didn't exist. So you'll see behind the scenes, it's going to crawl it again and insert the documents into our vector store. So now these documents are inserted. Now let's generate our report. And there we go. It searched the knowledge base, and this is what information came out of the knowledge base for this text. And then using this, it produced a research report for us. Now, behind the scenes, what happens is the open source models use the nomic embed text embeddings for storing the vector embeddings. If we do it for GPT-4, we have a notice here as well. When you go from between OpenAI and the open source LLMs, it uses a different embedding format. So you need to load the knowledge again. So let's see the results it produces with GPT-4. So we're adding this to the GPT-4 knowledge base. Again, it's going to scan it and put it to the research documents OpenAI table. Let's see that on the SingleStore SQL interface as well. So over here, you can see that the first one, research documents nomic. So this is the open source local working with Llama 3, that vector store, that vector collection. Whereas this is the OpenAI embeddings vector collection. You can query both of these tables here. You can see what's going on in them. We have an ID, metadata, the content, and the embeddings. This is what the similarity search happens on. Similarly, we have the same for OpenAI. And let's generate a report using OpenAI. And this is GPT-4 generating the report for us. I'm kind of not liking GPT-4 anymore when it comes to like Llama 3 with Grok. That is just something out of this world. Let's throw the hybrid search and let's ask it to generate a report on hybrid search. Behind the scenes, it's reading this URL, added it to the knowledge base, hybrid search, and there it goes. Look at that speed. Fantastic. Last one, let's ask, there's a choosing a vector database for your GenAI stack. Now, again, you can give this your own information, your own private information, your own company information. You can add a PDF if you'd like. Right after this is processed, you'll see a PDF. Drag and drop as well. You can add PDFs. With Phi Data, you can add documents, texts, anything you'd like. But this application, we've just specifically built it for websites and PDF documents. So we said, choose a vector database. And let's see the report it generates. Search the knowledge base and generated a report for us how to choose a vector database. Advantages, disadvantages, the hybrid approach, a bit about SingleStore DB, which is my preferred DB of choice right now, and filled with references and also a little bit of timestamp, which we provide. Fantastic. Now, let's move on to our RAG assistant. But before I do that, Vishwajit, Yukti, any questions?
We have some questions, but me and Akmal are taking care of in the back end. If there are some specifics, we'll save that for the later, right? Interesting
Brilliant.
demo. I think everybody is like the questions are good, which we are getting. And I think everybody is interested. So let's not keep them waited. Let's move to
Yeah.
Yeah.
Brilliant. I just want to show one last thing with this, which is this is running on Grok, but you can easily move it to Llama 3. And so this one is running entirely locally on my machine. A little slower than Grok, obviously, but Llama 3 8 billion model running entirely locally on my machine. You could use this right now free of cost as well. Okay, now let's move on to the RAG assistant. The RAG assistant is similar to the research. It'll take a URL to the knowledge base. It'll take a PDF and then answer questions. Now, right now, let's first ask vector search performance, SingleStore vector search performance. There is no data in there. So we'll be able to see what the LLM response generally is. SingleStore vector search performance. Of course, it's still going to be reasonably close, but not really what we're looking for right now. Let's add this blog post to its knowledge base. Is that added? Yes, it is. And now it gives me specific information from that blog post, something which wasn't there previously. So this is something which is why we use retrieval augmented generation to give very specific company information, specific knowledge to the LLM. So let's see what's happening behind the scenes. So I'm going to pull up my terminal. And actually, let's do this again. I'm going to clear the terminal entirely, refresh this. This already has the information. And ask the question again. Behind the scenes, it's going to start, and we'll see it's getting 3 relevant documents for the query. You can adjust the number of references from here, but I'd keep it under 5, 6 because the context window for this LLM right now is 8192 tokens, 8,000 tokens. So this is our system prompt, which is going. With Phi Data, we give you a nicely formatted way to get your answers. This is the user prompt. You can see all the knowledge base information from the article which we just provided being sent to the LLM in a format it understands. We do a lot of research with this. We've learned that the XML format is something which LLMs understand very well along with JSON. So we're providing them that. And then the LLM generates an answer with it. So this is, I asked, tell me about SingleStore vector search performance, and this is the RAG assistant. Can you compare SingleStore vector search to PG vector? And it gives me a comparison of benefits of using SingleStore against PG vector from that blog post. So that's our RAG assistant. Now let's give it a shot with Llama 3 running locally.
The model of the hour.
Yes, sir. This is Llama 3 8B. It is a fantastic model.
Yep.
As you can see, again, it mentions information from the SingleStore blog post. Can you do PG vector? This is fantastic. For an 8 billion parameter model running locally, free of cost, this is really good.
Yep. I think Llama 3 is going to be a game changer for people who are looking to build their private LLM apps, right?
Completely in agreement with you. The last thing which I want to introduce you all is this new concept called agentic RAG, or autonomous RAG as we call it. Now we're going to do this again from scratch. So you see right now we have the RAG documents from Nomic. We do not have them for OpenAI yet. So we're going to do GPT-4 Turbo, and we're going to add the document to the GPT, to the OpenAI with the OpenAI embeddings. So we're here behind the scenes, you can see that it's creating the table RAG documents OpenAI. Again, this is because the open source models are using the Nomic embeddings, whereas the OpenAI models are using the their OpenAI embeddings. Both cannot be stored in the same table. Neither can they be used for cross search. So now we've added that. Now I want to show you the agentic RAG or autonomous RAG. Tell me about single store vector search. Now, when you send this query with a regular RAG, it'll do a embedding of this entire statement and do a similarity search with it. Now, it's fine if it's a short statement, but if you put a half a paragraph in there, the relevancy results get worsened as the length of your input embedding increases. But with agentic RAG or autonomous RAG, the LLM decides what it needs to search. Now over here, you can see that it is searching the knowledge base for single store vector search. Now you can see that it definitely retrieves much better results using this approach. So this is our autonomous RAG or agentic RAG. And in my opinion, this year and next year, we're going to see a lot of applications moving from naive RAG to this method as well. So this was the question, and let's ask it again. Can you compare single store vector search to PG vector? Look at that. So it changed the query and searched for what it needed rather than what I was asking it. It knew what I was asking, changed that, and then sent it. Fantastic. Last thing, when we're building these assistants with Phi Data, under the single store AI apps assistance file, under the pages, you'll find the Streamlit applications. Whereas under the assistants, you'll find the code for the assistant. You'll see the RAG assistant over here. And you'll see that we can provide tools. So we mentioned that Phi Data provides memory, knowledge, and tools. So this autonomous bit, which you were seeing, is actually a tool that is provided to the LLM. So if I ask, what was my last question? It does a get chat history tool to send me my last question as well. So now instead of sending the entire chat history with the LLM in every API call, blowing through tokens and cost, we give it a tool, get chat history. And what it does is, listen, the user's asking for something from the chat history. Let me get the chat history from my memory as well, which allows us to expand the conversation length to infinite. Well, thank you all. Hope you enjoyed this demo. I'm going to be here for questions, but I did want to walk through step by step exactly how we ran this. So each of these steps, click on the research assistant, the URLs, click on the RAG assistant. We're available on Discord, chat over here, and finally the link is here too. Vishwajit, now over to you, and I'm here to answer questions.
Absolutely, Ashpreet. That was a very great demo. I think we have a lot of questions. I think you can also see. Let's start with the first one. Like someone is asking if we can clarify what is the difference between this approach, I think agentic RAG and the naive RAG. I think Ashpreet, I'll let you answer that.
Absolutely. So in the naive RAG, that is the step 0 of RAG, in which when the user asks, tell me about single store and PG vector, and give me an answer in 5 words. What in naive RAG happens is we take these 2 sentences and generate an embedding for them. And then we do a similarity search. So in this case, you will not get the right relevant answer as well, mainly because on the vector database, it'll not only going to search for single store and PG vector, but it'll also search for 5 sentences as well, because it's doing a similarity search. But in agentic RAG or autonomous RAG, as we call it, the LLM decides, okay, the user is actually asking for single store versus PG vector. Let me search that instead. So instead of giving the LLM information, we're giving the LLM the tool to search information as well. So it's simply saying, hey, the naive RAG is, this is a page of information, find the answer from this page of information and then answer, which as you can tell, won't work after the first or second or any complex cases. Whereas autonomous RAG is, hey, here's the entire book at your disposal, search for what you need and answer my question.
Awesome. I think we have one more question for Phi Data. How does Phi Data handle the complexity of massive data sets?
So Phi Data builds on top of with databases like SingleStore or others. So as SingleStore can scale, Phi Data scales with it. So on SingleStore, you can easily throw in GBs of information. We have clients right now doing autonomous RAG over thousands of documents and terabytes of information. Again, you do need a little bit of work on it. You do need to structure your process with it. But as long as your vector retrieval is quick enough, your vector retrieval is accurate enough, you can work with as large a data set as you would like. Again, you need some, once you go over the 10, 15, 20, 50 documents range, you need some fine tuning, you need some work on understanding the chunking and embedding. No one's calling this a silver bullet, but with databases like SingleStore, with the capabilities they provide with hybrid search, it becomes a lot easier than before.
Awesome, Ashpreet. Guys, I have also shared the link for vector indexes in SingleStore. If you have more than more than a million vectors stored, please check it out. You can reach out to us one-on-one. We will be happy to help you.
Yeah.
Right.
There's a question I want to answer about the security measures as well. And this is where Phi Data really shines. The platform is completely open source, which means you can run it in your VPC, on your data sets, completely in your cloud. So security-wise, when you run it in your firewall, no data is going outside, no data is coming in. It is as secure as a system can be. It is just another Python library for you.
Great. And most importantly, Phi Data is very developer friendly. So you can just start using it and you can create very good POC apps at a very fast speed, right? One more question, I think, Ashpreet, we both can take this. How does autonomous RAG work?
Yes, sir. So in autonomous RAG, we will give the LLM tools to search for information, either from its knowledge or its chat history, or the website or the internet. And using these tools, the LLM figures out, oh, I need to search the internet for this information. Let me use this tool. Oh, I need to search my knowledge base for this information. Let me use this tool. So instead of using regular RAG, you would search your vector database first with the user's query, give all your similar results to the LLM and say, answer my question. That stops working, I think, after like the third or fourth try. But with autonomous RAG, you give it tools to achieve what it needs.
Awesome. I think, do we have what case studies or success stories are available to demonstrate the value of Phi Data and SingleStore in AI application development? So for Phi Data and SingleStore, we have built pretty good demos. You can find them into GitHub repository of Phi Data under integrations, cookbook integrations and SingleStore. And you can also check out SingleStore spaces or our gallery page on our UI, our cloud dashboard, where you'll see multiple integrations with a lot of other technologies like OpenAI, Cohere. We have great demos as well. For example, we have a resume parsing and evaluation demo using LLM. That is something you guys can definitely check out. Yeah. One more question. Yeah, go ahead, Ashpreet. Yeah.
So I just want to address that with from the Phi Data side as well. While we don't publish directly case studies with our clients, we do have our software running and being used by hospitals, by marketing teams, by finance teams. So we build large scale AI applications with them on a one-on-one basis as well. Vishwajit, I just want to answer this question as well about, is autonomous RAG analogous to how math questions OpenAI has an add-on for Wolfram Alpha? Yes, sir, it is. It is pretty much a very similar model in which you give the LLM tools to achieve tasks. So it'll go to Wolfram Alpha for answering math questions. It'll go to the Bing search for getting internet history. In that case, what happens is that is on ChatGPT. So a lot of the memory, the knowledge, all of that is built in. But if you're working with the API, if you're developing your own AI application, Those pieces are missing, and that is what Phi Data provides for you.
Awesome. I think there's one more question for Phi Data. How does Phi Data interact with LLMs? I think we pretty much saw that. Yeah, Veda, you can explore the GitHub repository to check out the assistant layer on top in Phi Data, which we have built. I think that will help you understand exactly how Phi Data interacts.
Vishwajit, give me just a few seconds to answer that as well. So with Phi Data, we'll create an assistant class, an assistant object. An assistant object has an LLM, has a memory, has a knowledge base, which is a database like SingleStore, and has tools which are Python functions. And when you ask questions of the assistant, it'll either send it to the LLM and coordinates that orchestration for you. So it interacts with the LLM API, which you provide using, which authenticates using your API key.
Great.
Right. Thank you. I think there was one last
question. Yeah, I think I answered it, but I think we can take it up again. Like, how do you think Phi Data and SingleStore are changing the landscape of AI application development? I'll talk a little bit about SingleStore. So basically, you can use SingleStore for both your vector store and your conversation store. Like rather than using a dedicated only vector store where you have to do a lot of back and forth to retrieve the actual data or text data against the vectors. In SingleStore, you can have a single table where your text data and your vector data lives under the single table in two different columns. We also have a vector data type available where you can define the dimensions of vectors as per your specific model. You can also use our vector indexes, which can help you increase the performance if you have more than 1 million or into millions of vectors, right? And with Phi Data, I think Ashpreet will add more, but you can get started very, very fast. As you saw, we with just a few lines of codes, we were able to build an entire RAG assistant and a research assistant in a very short period of time, right? And I believe Phi Data is one of the most developer-friendly libraries I have came across for building RAG applications.
Thank you, Vishwajit. I do want to add a little bit on the vision which we're going after. There is an idea being floated around in the AI community of the LLMs as OS, where the LLM is a brain connected to knowledge, which is your database, and tools like the internet, like web search tool XYZ. But you have to build that LLM as OS layer. You need some sort of engine that coordinates those. That is the idea we're furthering with Phi Data. We wanted to be that layer that allows anyone to build AI applications and give LLMs superpowers, like giving it knowledge, which is RAG, which is very basic, which we're looking at right now, but making it more autonomous with tools as well. Thank you so much for that question.
I think we still have, I think, a few more minutes. And there's one more question. Is Phi Data competes with LangChain? What are the areas of overlap and differences? I think that's a very interesting question, Ashpreet.
It falls in the similar bucket. You can think of it as a cleaner, leaner, more focused LangChain, but we don't particularly just work with putting everything together in one place. As I mentioned, we are building on the idea of LLMs as OS. We do you can tackle similar problems pretty much because LangChain does everything. But Phi Data is very focused on giving LLMs memory, knowledge, and tools. That's about it. We do not deal in systems that do not work, like the React agent or other agents. We do not deal with them. We simply believe, give the LLM the ability to call memory, to call its knowledge, and to call tools. Put it together in a very clean, lean, and focused library. We have no dependencies. It's the leanest LLM library you're going to come around. While we do approach similar problems, our system is much cleaner and leaner from what we've heard as well.
Absolutely. Thank you so much, Ashpreet. I think this is the last question we'll take because we are in the last 5 minutes of the session. What are the key features and functionalities planned to be added to Phi Data and SingleStore in the future? Ashpreet, you can take the Phi Data part.
Yep. From Phi Data side, we are adding observability, monitoring. We are adding more tools, which are the basic nice to have features. But along with that, we're adding consistent evaluations, we're adding human review, we're adding the pieces that you need to take a POC, a demo application, and to run it in production for your company, for your team, and build it into a scalable AI application as well.
Yeah, with SingleStore, we are improving our notebooks experience, where you will also have a GPU integration with the notebooks, so you can run your LLM workloads on SingleStore directly. It could be generating embeddings, or it could be having a ETL job, which needs to be done for your RAG application, where the data is coming in real time. And with SingleStore pipelines, you can use the notebooks to automate that process. So as soon as the data is in, its embeddings are generated and stored for use, like making the embeddings or your entire data ready to use as soon as it's in. I think I'll hand it over to Yukti now. Yep.
Thank you so much. The presentation was so amazing. It was so interactive. And a big thank you to all the attendees for joining the webinar today. We really value your time and energy, and thank you so much wherever you are. And quick notes before we announce today's raffle winner. We've got great sessions coming up this Friday. We'll present Gemini 1.5 Pro native audio, file API, JSON mode, where you can see a live demo on how to leverage Gemini 1.5 Pro. If this topic sounds interesting to you, please RSVP right now. I'll be putting everything in the chat. On Monday, we have Is RAG Really Dead? Hands-on with Gemini's new token context window. And on Tuesday, which is the 30th, we have Llama 3 run locally with more power, less cost, full privacy. Hoping to see you all there. A big thank you again to all the speakers, Akmal for handling all the questions so flawlessly. And the announcement that you all have been waiting for. Today's raffle winner goes to Jug Jasani, who's a senior solutions engineer at Salesforce. Congratulations, Jug. We'll be emailing you and you can choose your prize. Once again, thank you so much for your participation. We really value your time and energy, and hoping to see you again. I'll be putting everything in the chat where you can register if you are interested in the future webinars that we are hosting. And thank you so much for joining. It was a pleasure having everyone. Thanks, Ashpreet. Thanks, Vishwajit.
Thank you all for having me here.
Wrap this up.
Yep.
All
Thank
right.
you.
Okay. Take care. Bye.
Bye, guys. Take
Bye.
care.